Welcome back, everyone, to the International Lighting Forum. I'm Ed Stocker. Thanks for being here. Thanks for taking time out for your lunch to be here. We have an amazing panel. If everyone who's off stage wants to come and have a seat, we're going to start our chat. Welcome to my esteemed panelists. I'm going to sit at the end. This is, of course, our first of two roundtables that we're going to be doing over these next couple of days. The theme is, they should be on, I'm hoping. You're looking at it. You're looking at the microphone worried. Hopefully it's on. So this is our Light for Life panel, and we're going to be looking at light quite generally from quite a wide angle lens over the next hour and a half or so. And I'm going to be a bit like we're back at school or something. I'm going to, first of all, then we're going to have a more dynamic conversation, I promise. I'm just going to ask you, even though people should be able to see you on the screen over there, a little bit of housekeeping. Manuel sadly can't be here. He's not well, so he's sadly missing out. But we have you four, which is excellent. So if you can just briefly introduce yourselves and explain your relationship with light. I'll start with you.
Good afternoon. I'm Piero Benvenuti. I am currently Emeritus Professor of Astrophysics from the University of Padova. So my relation to light is through astronomy. I was fascinated by the light emitted by the stars and the objects that I can see with a small telescope when I was a child. And then I developed my passion for astronomy more professionally. And I was involved particularly in astrophysics from space, the one that we can observe objects outside the atmosphere, and so we can get the entire electromagnetic spectrum from the object. So that is my relation to light, and it continued to be after I retired from the university.
Shelley.
I'm Shelley James. I'm an independent lighting design consultant. I help clients to save time and money and manage risk when it comes to thinking about investing in lighting, because there's so much amazing science coming out there. It's really hard for people to understand, sort of see the wood for the trees and make some better decisions so that they create a cost-effective solution. And that sometimes involves working at the very early stages because the world doesn't necessarily need a new light bulb. And it also goes through to working out, bringing in specialists when we need them, bringing in post-occupancy surveys. But my interest with light started, I'm going to bring out my...
You got some props.
My interest in light started when I was born in Jamaica, so I lived all over the world and was really fascinated by the way that light was different in all the places that I lived. And then I had a head injury and really shook this thing around, and you've all got one. Otherwise, you wouldn't be here. And I had to retrain the connections in my brain, which led to me being fascinated with light. I set up a social media campaign about light for teens, which went viral. Then I ended up doing a PhD, a whole bunch of other stuff. I'm a well advisor, I'm a TEDx speaker, written a couple of books. So now I'm a kind of tour guide to bridge the gap between the science and practical applications of light all around the world, which is great.
Well, I'll be relying on you to do that today. And you've got another prop that you might be getting out later. We'll get that out at some point during the course of the conversation. Nicholas, over to you.
Hi, Nicholas Belfield from DPA Lighting. So we're a lighting consultancy working on projects. Sorry?
A bit louder.
A bit louder. Working on projects around the world, and projects ranging from we do design for bats. We've done that. It's a bit of a left field thing where we're trying to basically get rid of light in residential developments in natural circumstances. And then all the way through from small residential projects and retail, all the way through luxury hotels up to huge master planning projects. So my relationship with light came from, I studied as a product designer or industrial designer, as it was called at that time, and worked in a lighting company designing light fixtures. I then later moved on to a company that was a lighting design consultancy and had a special product department designing light fixtures. And seeing the lighting consultants doing their projects and seeing how light interacted with spaces and people, I gradually started to realize that my passion was perhaps more in that area in terms of light, dealing with light itself rather than a product. So I gradually moved from a product designer into a lighting consultant, and here I am today.
Okay, Roger.
Hello, everybody. My name is Roger van der Heijden. My relationship with light is that I make my living designing light. I'm a lighting designer, and I take ideas into experiences. I ask questions about light to my client, and then together we find the answers. I am in particular also interested in glass and how it interacts with light and how I can make that.
Okay. Well, I mean, as I said a bit earlier, we're going to sort of delve into light generally and hopefully have some more detailed questions as well. But I'm interested really for us to really talk about the essence of light. And Piero, my question for you is sort of, we didn't really exactly fully know what light was until around the 1860s. Is that correct?
Yes, absolutely. And of course, humanity was puzzled about the nature of light since the dawn of civilization. But it was only, as you said, at the middle of the 19th century that we discovered what light was or is. Of course, along this history, we had a lot of knowledge about the behavior of light. We knew how it's blocked by object and casting shadow. We know that it's reflecting by shiny surfaces like mirrors. We were puzzled by the strange appearance of objects immersed in water. We were even more puzzled by the dispersion of light going through a prism. That makes clear that white light is composed by colors. All this was very well known and in fact was also described mathematically, but the nature of light was still a mystery. And even the speed of light was measured accurately. The first determination of the speed of light is made by an astronomer, a Danish astronomer, Ole Rømer, who was using the orbital period of the satellite of Jupiter, which were discovered just a few decades ago before by Galilei, and observing the period which was changing along the year, because when the Earth is moving away from Jupiter, the period was longer, and when it was approaching Jupiter, it was shorter. And with that, he made the first estimate of the speed of light. Galileo himself tried to measure it with an experimental setup that was bound to fail because he was just using an assistant with a lantern, making light signal from a distance, and at best he could have measured the reaction time of his assistant, but not certainly the speed of light. And with this Rømer estimate, it was clear that the speed of light was really fantastic, very, very high. And then by the mid of 19th century, the light was measured in the laboratory very accurately, and we know that it's about 300,000 kilometers per second. Nonetheless, the nature was not known. And it was discovered by a great physicist and mathematician, James Clerk Maxwell, a Scottish physicist, who at the time, in the mid of 19th century, was working on the mathematical equation describing the behavior of electricity and magnetism. Two phenomena that were known from antiquity, but they were considered completely separate, completely different. By the time of the 19th century, it was becoming clear that the two phenomena were linked together. If you move a copper coil across a magnetic field, you generate a current in the coil. And conversely, if you make a current flowing in the coil, you generate a magnetic field. And so Maxwell was describing that in 4 mathematical formulae, and he was trying to join them together in a single one. He was a very good mathematician, so he made it that using a mathematical formulae. And when he put together the two of the two equations, he found that the resulting equation was very typical of equation describing the propagation of a wave. Any type of wave. Could be a water wave, can be a sound wave, can be a string wave. But that was a signal that light was a wave propagating. And the nice thing was that in the equation, the constant of this equation represents the speed by which the oscillation is propagating. And using the data that he had from the electrical experiment and magnetic experiment, he could compute from the formula the speed of light. Well, sorry, the speed of that perturbation. And I must say, I think that he jumped on the chair discovering that that velocity was exactly the velocity measured for the light. So at that point, from that point on, we know that light is an oscillation of an electromagnetic field. The electric field and the magnetic field oscillate perpendicularly to each other and perpendicularly to the propagation of the perturbation. And the perturbation, light, is moving at this fantastic speed of 300,000 kilometers per second. From there on, we open a totally new window in physics and in the understanding of nature, because then we can use technology to create sources of light. And from there on, of course, it started with the urban illumination using physics, and not just using flames or using gas flames or fireplace. And we have this revolution. There was also a revolution in astronomy, because astronomy became astrophysics, because by analyzing the light, which we now know the origin of which, it was possible to start understanding the nature of the object emitting light: stars, nebulae, galaxies, all the objects in the universe. So it was really a fantastic feat for the knowledge of nature. And from there on, we started really using light in a more knowledgeable way.
Shirley, thank you for that schooling. You've educated me there. I want to talk to you a bit more about science, Shadi, in a bit, but I'm going to ask Roger and maybe Nicholas over on this side. I'm just interested. Obviously, you know, there's such a big part of any discussion about light that is very science-based. Obviously, you're lighting designers. How do you use that information? How much do you delve into science yourselves? Maybe, Roger, you want to go first, and then I'll come to you, Nicholas.
Well, first of all, it's very interesting. I'm a curious person, so I want to learn something. And today I already learned a few things, so thank you very much. I like to learn about all sorts of things. I am working with glass a lot. I am currently designing a big facade for the new Museum of Modern Art in Riyadh, in the Kingdom of Saudi Arabia. There is a lot of sunshine, and I want to understand how the glass modifies or modulates exactly the light. And when I am inside this museum and I have an experience of the architecture and the artifacts, the artworks, and also the light, how that all plays together. So I have to understand how the color changes, how it breaks up the light, what kind of texture is created. Because as I said, I have an idea, but I want to turn it into an experience. And there's a lot of knowledge needed for that. So obviously, I know some things myself, but I collaborate with people who know much more in these fields. And that makes it super exciting to do this kind of work.
So from our point of view, we're very lucky that we have in our teams, we have people from all sorts of different backgrounds. We've had people who have been astrophysicists, in fact, and you know, all the way through to theatre designers and architects, interior designers, product designers like myself. So, and people react differently. So some people have a real in-depth knowledge of the scientific side of lighting. Some people just come from it from a much more emotional side. So it's very much dependent on the individual person, and you know, to a certain degree, we do sort of brush across the top of the science. You know, in our everyday work, we don't delve deep down into the science of lighting. You know, and particularly now that we're getting, you know, programs like Dialux that do calculations for us. We don't even do, you know, we used to do hand calculations back in the day when I first started, but now we just build a model, put some lights in it, and it does it all for us. So there's a sort of it's the kind of thing that's really interesting for us, and when we occasionally let ourselves down and let ourselves into a situation like this and start to think about it a lot more. But I have to admit, on a day-to-day basis, we don't really delve deeply into the scientific side of it. It's much more of an emotional response to a space or a client or whatever. So yeah, I'm embarrassed to say that we're not scientists. Something we talked about earlier, the depth of knowledge that the guys on this side have compared to myself in terms of the scientific side of lighting is amazing, and and it's always good to occasionally call upon that and remind ourselves where that lighting actually comes from.
I asked this question earlier. Should there be more collaboration between these two sides? You've divided yourselves without me asking you to, by the way.
We can change seats if you like. It's okay.
You should maybe swap. But should there be more collaboration, do you think?
Well, no, not necessarily. I think there's so much room to design lighting in so many different ways. Like when I listen to Nicolas, I'm super impressed. I mean, they run this super big professional office with software, and they can work all over the world, and that's just a really great way to deliver very consistent, high quality of lighting planning. And I'm just alone, and I team up every time with other people that I find, so I can create a very curated process, if you like, which is very much different all the time. And I unfortunately don't know how to operate the program that you just mentioned. But it's not needed because I see the application of light in a different way. And I think that's the beauty of lighting design. You can approach it and tackle it in so many different ways. I like the collaboration with a scientist and go really deep and spend 5 years on a project. That may not be possible in another practice, right? And that's fine. I mean, I'm not ranking these. I'm just saying it's just so interesting that people can work with light in so many different ways.
I remember you were saying, actually, Roger, when we chatted ahead of this, we were sort of talking about some of the science-based things, and you said to me that for you, lighting is much more about emotion. So maybe talk to me about that, because there are all these things, and I'll bring Shelley in perhaps after, that light does to us as humans. But at the end of the day, is it just about emotion?
I won't answer this right away, because I think that a lighting designer like Nicolas deals with the emotional aspects equally. I mean, right? I mean, it's super important.
Yeah, of course. I mean, as I said earlier, the emotion of lighting and the emotion of looking at how people use a space and how lighting can adapt to that is one of our main driving forces. We are there to serve their clients, and if not the client, the guest who uses a hotel, or the resident who lives in a house, or the worker who goes to the office or studio that we design. So it is an emotional response, but I think conversely we do need that the science to guide us and continually to develop things. And I think one of the conversations we'll come on to later is about how lighting affects us and circadian rhythms and things like that, which is a very scientific-based subject, which is slowly pushing itself into commercial lighting design, and so yeah, I think science is important. I think it's probably in a lot of big commercial projects we perhaps don't get the time to work with scientists as we would like to and develop. So it almost needs to be a sort of secondary outside of the coalface of a commercial project where time is money effectively, and people got deadlines, and and deadlines are becoming much shorter these days. Our conceptual stages are becoming crazily short. We don't get the time we used to think about things in the way we used to. So yeah, having a scientific backing is really important, but perhaps not something we get to do day to day.
Were you going to say?
Just very briefly, I think I misunderstood the question at first, because when we deal with the emotional side of lighting, that could be that whole science of the neurotransmitters and the wake and sleep rhythms and all these sort of things, and do we feel fatigue and in bad lighting, or are we scared when we enter the underground because it's dark, or all these, we can explain all of that also in a biophysics way. And I think there's also a sort of like a non-measurable idea of emotions, which is what you experience when you see Hamlet in the theater, and I don't know, it gets green and scary, you know. I mean, that's culturally defined. We cannot really explain it in a scientific way, but it's equally important. So I think the question is more, I mean, I'm not leading the conversation, but I think it's for Shelley the question.
No, my question was actually more
answer
to do with, that sort of base core reaction that you had. That's what we were talking about on the call. But you teed me up perfectly to bring in Shelley. I mean, let's talk about, because I know it's something you talk about a lot and you've studied a lot. Let's talk about the effects that light has on the body. I mean, you said it before in a TED talk, you know, but it's incredible just all the thing that light can regulate. So maybe you can just enlighten, if you'll excuse the pun, our audience about that.
Sure. I mean, every single cell in your body is responding to light right now, and it's been doing that from about just a couple of weeks old in the womb. So it's been doing that for a long time, and it's defining every single thing. It's defining how much how awake you're feeling, whether your eyes are feeling a bit scratchy, all kinds of stuff. Particularly those of us who flew in from other places yesterday, our body clocks are being defined by the amount of light we got this morning. So every single cell, in fact, I mean, about 30% of the calories from your lunch are being burnt processing visual information. And we used to think that, so you've got light coming in from your eyes. Here we are.
Got the second prop out.
And that's, the back of this is a piece of brain tissue, and it grows about 65% from birth till you're a teenager. So if you've got kids, you need to make sure they get enough light, otherwise they're more likely to get myopia, for example. So these basic, the hardware development of your visual system and your neurology is set up very, very early on, and we can continue to support that through, as we get older and as we go into as those of us who have slightly spiky profiles, we're more or less affected by light. We're all different. So every single cell in your body is doing that. It's doing that. We used to think it was only doing that to visible light, but it turns out that it's doing that to the full electromagnetic field, so infrared, ultraviolet, all of that stuff. So just to finish off on how it's affecting us and why it matters for you guys maybe to understand a little bit about that, to just kind of it's mostly because, anyway, let's start with this. So we have an acute alerting effect. The brain is evolved to kind of notice bright stuff. It moves towards brighter areas or recoils depending on the situation. Your visual cortex, so the light is coming in through your eyeballs, back in here. The light that came to you from the sun set off about 8 minutes ago, and it takes moments to hit the visual cortex at the back. But actually what's really interesting is what's going on in the middle of your brain, and that sends a signal to your body clock, to your adrenal system, a whole bunch of other mood-setting things, which is why SAD lamps work, for example. And it sends a signal directly to your brainstem. So that's to make a pitch for understanding how light is affecting your chemistry and your biology and your responses, because a lot of the decisions we make today are kind of default. And if we go back to first principles about why things work the way they do, then you can start to be a bit radical about how you design stuff. Because you kind of go, well, it's always been done this way, but what would happen if we knew more or we tried something different in these settings? So that's my argument for the science, because it allows us to think outside of the box of a lighting system and specifications which have been designed based on lumens per watt and a particular lights on the desk. All those sorts of things are designed for quantity, not quality of light. And now we understand that this thing is responding to quality as much as quantity. And I sometimes use the analogy of calories. So you think about, if you're going to give your kid, you're going to give them a Mars bar or an apple, they're going to be getting perhaps more or less calories, but you can see how the way they're delivered is different. So that's my pitch for understanding the science of light. It's to do with making sure that you have choices, informed choices, and that you aren't just going for the default.
That's good. Maybe Roger and Nicholas are going to have a think about that. Piero wants to come in.
Can I jump in on this?
Please do.
Since I see the hardware here, I think it's very important to understand that the hardware in there is composed with two receptors, completely different in nature, and these are the cones and the rods, which maybe are we don't need it because they are very small. But the point is that the cones are those that give you the possibility of seeing in color, because there are three types and they are sensitive to different wavelengths. And so the combination of that makes the possibility for you to see that that lady is red and then that is white and it's green. And if somebody doesn't have that possibility, then it's a kind of disease, but I mean, still. And that cones act when the level of light is reasonably high. But we astronomers that are used to look at very faint objects in the night, when in general there is darkness and the only light is the one coming from the cosmic object, then we're using a different type of receptor that most of the time now, today, are not used. And those are the rods. The rods are sensitive only to one wavelength. And so there is this say, at least in Italian, that says all cats at night are gray, which is very true, because if the level of light is very low, you don't see the colors. However, these rods are much more sensitive than the cones. And they are very sensitive to light. So the chemical reaction, biochemical reaction that activate the rods get completely saturated very soon if you have a flash of light. If the level is high, then they become saturated, so they do not respond anymore to light. And the function of vision is transferred to the cones. In fact, we astronomers, when we want to observe object with a telescope, have to remain in darkness for about 20 minutes before all the biological reaction go back and becomes active again. I just mentioning this because you need to realize that this great hardware that you have in our eyes is used only half the way currently, because normally the light level is so high that the poor rods do not participate to the adventure. But if you are patient enough during the night and you wait in the darkness for about half an hour, then you should know that what you see is through those fantastic rods. And then you can see the very faint object in the sky. I will come back to that later on.
Can I just add something else? So, I mean, those rods are sensitive to just one photon, aren't they? They're amazing. But about 20 years ago, we discovered an entirely new class of photoreceptor on the top layer of the retina. So this bit at the back of the eye is called the retina. It's a piece of brain tissue, actually. In early space flight, they used to look at the retinas of astronauts to see how their brains were coping, because they couldn't chop their brains open at the time. But the top layer, about 5% of those have a completely different light sensing function. They're called intrinsically photosensitive retinal ganglion cells, or iPRGCs. And they have a protein called melanopsin in them, which is sensitive to sky blue wavelengths. Surprise, surprise. And that mechanism is, so sensitivity to sky blue wavelengths is what drives the circadian cycle. So you'll see that lights which have enough of what we call melanopic lux in the morning will help you to sleep better at night, for example. So the more we understand about this stuff, the more exciting it is. And as you were saying, light after dark is much more stimulating to your body clock. It keeps you awake much longer than light during the day. So this is an amazing piece of kit, and we're just learning more and more about how it works.
Okay. And also in terms of that sort of sensitivity to light, we talk about, needing to get a certain amount of natural light every day, and having that exposure. A lot of us, most of us, I think that's right, Shelley, you were saying to me before, don't spend enough time outside getting the light that we need. What I'm interested in this conversation is, obviously we're inside, we're surrounded by artificial lights. We're in the lighting section of Salone del Mobile. I want to know if, some of these benefits that we talked about, the way we can regulate our body clocks, we often think about that in terms of natural light. And obviously we need that, but I'm wondering, because you talk about harnessing the power of the light bulb, don't you? How can we get that from artificial lights? How can indoor lighting be beneficial and good for us?
It's a great question. I think natural light is obviously the gold standard. Actually, natural light and darkness is the gold standard. But we now know enough about what the active ingredients are in that wake-up response, in that alerting body clock setting response, to be able to tune or kind of engineer the wavelengths coming out of a light source to deliver enough of those wake-up wavelengths, like coffee, to people's brains, particularly older people or people who don't go outside enough, to see the changes in the way their body clocks are working. So when we apply these principles to residential healthcare, for example, when we give enough of those wake-up wavelengths in the morning, and we make sure it's much less in the afternoon and completely dark at night, we see an incredible improvement in the quality of sleep. We see things like a 43% reduction in nighttime falls. So we see some really substantial results in terms of the way that their body clocks are setting. And we can do that in settings where people are working shifts. So we can set people's body clocks up when they're working nights so that their body clocks essentially start to run correctly, so they synchronize. We can also see that in offices. So if we deliver enough melanopic EDI in the morning, we see improvements in sleep at night, because your brain is like a photon counter or like a step counter, and if it gets the right amount of light at the right time, it sets it, it tells it what to do next.
But do you need a special, if you like, light for that?
Well, special, it depends on what you mean by special. All the lights in here, I've got my light meter and I left it in the back, but you need a light which is designed to help people be their best during the day and potentially tune or change the spectrum so that it allows them to relax or to switch off. So that's special in that most of the lights in this amazing, these gorgeous decorative lights don't come anywhere near the light levels that you would need. Some of them do. And it's just about deciding what you want the light to do and then engineering the spectrum to deliver that. And it's not rocket science. It really isn't rocket science. People have been doing it for 15 years, so it's not rocket science, or even that much more expensive.
Roger wants to come in, I see.
Well, I thought maybe it helps to give like an example from the real world. Like in the city of Groningen, it's from the Netherlands, right? There is an academic hospital, university hospital, with 32 beds on the intensive care unit. And I really hope you will never be in the intensive care unit, but if you happen to be there, you will see there's always light around you, always noise, always beeps, always blinking lights. It's a terrible place to recover or to cure, but it has to be like that. And the biggest, one of the big risks of the intensive care unit is that you don't sleep anymore because of all this disturbance and all this, let's say, bad lighting. So we worked very closely with the scientists of the hospital and with the intensivist, let's say the boss of the ICU, and we developed a panel above the bed because you're on your back typically. And it changes slowly color in sync with what is supposed to be a good rhythm for your sleep and wake. So we use amber and sky blue. We just keep it very simple. Exactly as Shelley says, it's not at all complicated. Everybody can do this. You just need to team up with each other, have the scientist and the lighting designer and the engineer in one team, and you create a true solution. Because what they see in Groningen is that people, on average, leave the ICU 1 day sooner than before. Now, that doesn't sound like a big deal, but it is a super big deal. because it saves a lot of healthcare costs, about 7,000 euro per night. And it saves lives, because, I mean, you come out of the ICU either dead or alive. That's the reality of it. So you better leave sooner, and you can recover in a normal hospital bed than staying there too long, because the mortality only increases then. So this is just a real-world example of the principle of the sky blue light that helps you to wake up, and the opposite of it, the amber lighting, and we all know this, that helps you to get relaxed and to see if you can fall asleep. There are more examples. We did the Boeing sky. If you came here on an airplane and it was a modern Boeing aircraft, you see the lights changing in the ceiling. It is synchronized with the time zones that you travel through on longer flights. And there are more examples. They don't come to my mind now, really, but we did a lot of stuff like it. The ambient experience, of course, of Philips, that was also designed by us, which is also in the hospital, where you go in one of these scary body scanners, you know, the MRI scanner, and it makes a lot of noise, and it's very discomforting. And the light is soothing. It helps you to relax and to release some melatonin in the blood cycle, which is the neurotransmitter that makes you like feel, you know, able to fall asleep. And the doctor is also very happy with that, because the scans are more successful, because people are supposed not to move in this device. And if you tremble because you're discomforted or anxious, then the scan has to be done again, which is again expensive and time-consuming. So there are a lot of real-world examples of this science that finds its application in just, frankly, very simple lighting design.
Yeah, I'm just going to add that. So those are the places where people say, oh, that's fine, that's just where people spend all day and all night. But actually, if we were to turn these lights on to full, or if there was a way to do that, some of you who are valiantly staying awake but struggling would suddenly feel a lot more awake. It's not rocket. There is an instant alerting response. And we can also see in spaces where, in office spaces, where you have people who prefer to be in brighter, cooler lights and others who prefer to be in softer, warmer lights. We see occupancy. Some of the case studies at the moment that I'm working on in offices, they see greater occupancy, and everybody's trying to get people to come back to the office, and the most expensive desk is one that nobody's using. So creating spaces that people want to go to and feel they have a choice. And the other thing that might be interesting to think about is controls, because when we ask people who work in offices about the single most important thing for them in terms of IEQ, or environmental quality perception, control over their environment is top, and control over the light switch comes out very often top as well. So simply being able to control your environment or choose spaces which fit your style of working makes a big difference to the way that offices function. So it's not, and that's based on what we know about how this thing works, along with the magic and emotion that you bring in.
Nicholas, I'm going to bring you in. Shelley was talking about adapting offices. You know, one thing I learned during the course of speaking to all of you was this idea that everyone adapts to light differently, that there's not a single way. We might, you know, light may appear more intense to one person, so everyone's unique. Obviously, there's a sort of term that gets thrown around a lot, this human-centric lighting, which is a bit of a catch-all term. But what does that mean to you? How do you try and adapt that in the many, many projects that DPA does? And you know, are you looking to do things like Shelley mentioned just then, have things that are very customizable and adaptable to your clients or even individuals?
So, I mean, in terms of a human-centric or biocentric, or there's lots of different catchphrases people are using. For us, I think we kind of missed the first round of that introduction into the industry, because it was very based on office lighting, because at that time it was quite expensive, so it needed a cost benefit, and so the cost benefit was, oh, you know, you'll get it paid back because your workers are much more alert, they'll be much more efficient, they'll produce much more work, so basically, you know, it pays itself back in 2-3 years or whatever. So, excuse me. So that sort of came into the industry that way, but as our consultancy, we often get involved in office projects, but not necessarily the actual sort of big office floors where we're probably talking about where it first came in, because those tend to be done, the design can be done for free by a supplier, manufacturer, as part of a supply process. So we miss that kind of first round of circadian human-centric lighting. But we're finding it coming in more and more in different ways. So we're getting well standard is coming into a lot of projects, and obviously well standard refers to circadian lighting. It also, I think, references the EML, the equivalent lux, which is something we're sort of starting to grapple with, and that's probably where the science does come into our lives, because it's a little bit more complex than normal lighting calculations. And I believe you need a melantopic ratio from the manufacturer, and so this.
Well, yes.
To try and so we haven't actually been pushed to make those calculations yet. And what we are finding, I'm sort of digressing a little bit here, is that often when we have those standards on projects, we also have a competing lead or ASHRAE of a sustainability standard that we need to apply to. And so often, the well standard is saying, well, your office should be brighter, it should be, a higher, uniformity around a desk or whatever. But obviously that means more installed watts per meter, etc., which then obviously is opposed by the, if we go for LEED Gold, we need to be ASHRAE plus 30% saving, which is really, really difficult. And obviously because so they combat against each other. And what we're finding at the moment is that sustainability wins at the moment, because that's a catchphrase that everybody, and a catch point that everybody wants to follow and be a part of. So the well standard tends to go, okay, well, we won't go for that point, we'll go for a different point, so, which is unfortunate. But the other way we're finding is that actually where we are becoming into contact with more scientific-based people and other consultants who are very focused on human-centric lighting. So we've had a couple of projects recently. One was an elite sporting facility, so a super highly confidential project, where basically they were trying to not only introduce circadian lighting into the office areas, the backroom staff and the general areas for the athletes, but also they had a room which the company we're working with had recipes, they called them. So effectively you could put an athlete into that room to help mitigate jet lag if they've been traveling the world, or to help recovery time after training, or they had lots of recipes, they called them. So there was lots of different things you could do. So you got basically put in a room and they put you through a recipe of light. So different brightness levels, different color temperatures, etc., to help you through whatever, or improve your performance, or relax you, or mitigate jet lag, etc. So that becoming perhaps a little bit more, rather than trying to work with our circadian rhythms, that was almost like a, trying to adapt them and push them and change them in a sense, So we had that, and then there was another project which was a similar consultant came on board, and it was a super high-end hotel with a spa, super luxury. So the spa is in the basement, as they often are. So they wanted to follow daylight rhythms, etc. But again, that was getting into much more sort of almost medical procedures. So the spa gave, as well as the normal treatments, it was sort of non-invasive cosmetic treatments as well. So, and that was all the way into the light masks, the red light masks that help produce collagen, etc., to doing things to relieve back pain. And so it was using light into a way more sort of medical and scientific way than we ever sort of deal with. So we were kind of dealing with the as I said earlier, brushing across the surface of science and doing the sort of day-to-day stuff. But the other side of that is that something we've been pushing, and we'll talk about technology probably a little bit later, but what we've been pushing is that it's only 10 years ago that we could only get 3,000 Kelvin was the warmest color temperature in LEDs. We were really struggling to get good quality, high color rendering, warm LEDs. So we would have hotel rooms that you dim them down and they looked gray and grainy and horrible because it was just 3,000 Kelvin dimmed to probably 30%, because then the LEDs wouldn't dim anymore and go off. So we went through a pretty horrible period where we went into energy efficient lighting, where we lost a lot of those relaxing, beautiful, warm, rich environments that we used to be able to create with tungsten. So we've been pushing dim to warm and tunable white technology, so allowing us to control both the light level and color temperature. So what we've been trying to do is introduce those more relaxing, cozy, warm environments, because conversely to where circadian lighting first came in, where we were trying to pump blue light and a lot more light into people to wake them up in the morning and make them more efficient. We're all victims of looking at our phones at night and getting more blue light than we should into our bodies. So it's a completely non-scientific thing that we've been doing. But
so we need cozy low light now.
It's just cozy. Yeah, we've been basically trying to create cozy environment, so an environment that you can relax in at night time or after, one thing we put forward was after a busy day shopping in Oxford Street, had a lovely hotel just off Oxford Street, was that you could come back and switch on the level lights, and it was at a really nice low level, almost amber, beautiful and relaxing. And so it's a sort of, that was a completely emotional response to our feeling of what we'd been stuck with before. It wasn't scientific, but then now you start to talk about it, oh, actually, it is scientific, but again, just brushing across the top of the science.
I'm just going to jump in on the perceived tension between delivering enough light in the morning and delivering energy efficiency, because what these ways of thinking are doing are forcing us to think about when we put the light, where and who for. So I think if you're looking at connected load, then you're going to struggle. But actually, if you're looking at placing the light where people are at the time where they are and using dimming and other techniques and daylight harvesting, there are lots and lots of techniques. I work with BDP, for example, a lot on these calculations and see how we can actually beat BREEAM and LEED into, no problem at all if you step back from the lumens per watt coming out of the light bulb and actually think about the lighting scheme with more intention.
Yeah, no, I mean, that's we often, and we're trying to fight continually, is because this whole installed load is a bit of a nonsense in a way. But it's, obviously it's an easy way to quantify and measure lighting, energy use. But it's not correct because, particularly as talking about tunable white, where you have, effectively two different white light sources, we're never going to use that 100% for both running at 100%. And yet, when we do those calculations for installed load, we have to calculate it as 2 times 9 watts or whatever. But actually, we're only ever going to use 9 watts, not 18 watts. So it's kind of, we need to move on as an industry. We need to move on from this installed load because it doesn't cover what we need in lighting. And I've just come back from a hotel project where we were setting the scenes, and in none of the scenes, even the cleaning scenes, did we have a lighting at 100%. And in fact, 2 out of the 4 scenes in many of the spaces, a lot of the lights were turned off completely. So, we are in a situation, and particularly when we're talking about, Shelley says about installing lighting which is beneficial for us, that we need to look at it in a different way. We need to, how that's compared with energy efficiency, because if we're talking about it being very dimmed and low in the evening compared to very bright in the morning, then we need some metric to understand how we are using energy, and not just say, okay, you've installed 18 watts per linear meter here, that, tick, off you go. It needs to change. We need to move on.
I want to bring Piero in a second. I want to talk about actually the sort of flip of all of this, which is the absence of light. But maybe I'd just ask you, Roger, first of all, what your take is on, before we move on this idea of human-centric lighting as well, to get your opinion on it.
Yeah, I also, I will try to answer that, but I also wanted to build a little bit further on everything that Nicholas explained, because basically this is about rules and regulations and recommendations to make lighting better or more responsible. You mentioned well and LEED and whatever, ASHRAE and all these things. These are codes. And yes, they are maybe not exactly delivering perfect lighting, and I'm not even very familiar with them, but I think there are a lot of people here in the room, interior designers, architects, maybe even stylists or other people engaged in lighting, electrical engineers perhaps, and it is part of their job also to make a lighting plan every now and then. And I think they are actually helped also by having some sort of framework, at least not to make the big mistakes and learn something from how they can improve the way they plan lighting. So I see it, on the one hand, I'm totally with you. I do not like very much these codes in my work, and they don't play a very big role in what I do. I also mostly work with natural light, with the light from the sun and the sky, and how it plays out in buildings, making an experience. But even then, the codes apply, of course. But it usually works out fine, I must say. But there's also this very big part of the lighting industry full of professional people who are sitting here who are not an expert because they are dealing with lots of different things. And I think it probably helps you a little bit to get some guidance by means of a recommendation or a code. That's what I wanted to add. Your question was how this works for me, like the emotional bit of lighting and how important that is, perhaps.
Well, I was asking about human-centric, this idea of
Yeah.
human-centric lighting, and just, if it's something you even
But
think about, if it's a term you dislike intensely. I don't know, I
No, I
wanted
don't
to get your
dislike
take.
it intensely. I just think it's so broad and so general, like human-centric lighting. I mean,
Well, so is the word,
first
like
of
the word
all,
sustainable. It's pretty
First
pretty
of all,
generic.
I want to make light for all forms of life, not just for humans. I think that's also important. I mean, especially when we make the lighting outdoors. Even in the city, there's a lot of nature going on. Insects, bats, you mentioned briefly, birds, trees that don't grow well because there are lanterns close to them. I mean, there's many reasons to consider all the forms of life on Earth when we plan our lighting. So human-centric lighting, I would rephrase and call it life-centric lighting or something like that, right?
Yeah,
I
good
think
point.
that would be very clever to consider things that way. Secondly, I think that when we talk about human-centric lighting, we think of our wake and sleep rhythm, we think of shifting the color, modulating the brightness, and that's about it most of the time, right? And there is so much more about human-centric lighting. I mean, lighting for people is light that can tell a story or evoke an emotion or make us feel really comfortable or confident to go into somewhere. And that has not much to do with the neurotransmitters and the hormones, to be honest. I mean, not that I am aware of, at least. I don't know.
Well,
you will say it has to some extent, I know. But I create these things based on my experience and my own feelings. And so far, it seems to work out well. So, yeah, I mean...
I'm not saying that... I don't think there's a tension. All I'm saying is that there's a way to trace what's happening into other dimensions. You have a...
most likely.
That's what I mean. I don't think there's any difference. It's simply perspectives on a particular outcome.
I'm with you. But it's also nice to think that light has this slightly enigmatic and mysterious dimension that we cannot explain with the rationale.
Mm-hmm. You want it to be intangible almost. I want to bring Piero in because he's been quiet for a little bit. And we were talking about this absence of light. I was teeing it up earlier. And I know it's something that's sort of dear to your heart. We talked a lot in our conversation before about dark skies and building on that point about not just human-centric, actually paying attention to nature around us. How important with the ever more affordable use of LED lighting, tunable white, how important is it to think about that abundance of light and try and perhaps rein it in?
Yeah. Well, I would start saying that the invention of LED was really a fantastic scientific and technological feat because you can have the same level of illumination with an order of magnitude less energy. And so that is a great thing. But of course, it has also the bad part of the coin, which is the fact that lighting then became immediately very cheap, much more cheaper than before. And so the tendency, which is not a smart tendency that we have listened here, was to use that cheap light to have an excess of lighting. And people didn't think about when light is needed, where and at which level. And unfortunately, this is linked to economy because people start using light for advertisement, for commercials. And you have to question how useful is that? How useful to men is that? It's useful for people who want to make money with that, but not because people want to live better. And so if you look at the images of the Earth taken from space, you see that there are regions in the Earth which are completely polluted with light. And that is just stupid, because the light that you see from space is lighting going up in the sky, where it's absolutely not needed.
Just wasted light.
It's completely wasted. And the fact that it's cheaper doesn't make that better, because you should use the light intelligently and smartly. And then the result of that is, for a large part of the inhabited region in the world, the sky, the natural sky at night, is not visible anymore. Now here in Milan, even if today is a nice clear sky, tonight you see up, and maybe you see the moon because it's bright enough. But if you look for constellation, you see only the very, very bright stars. Now, I'll come back to the emotion that it was mentioned before. Certainly, light is creating emotion. If it is used intelligently and artistically, then it's really making emotion. But there are other type of emotion. And there is one which is not completely understood by people. And I want to go back a bit. Sorry for that, but I mean,
Oh, please.
I put some background on this. You should know that our understanding of the total reality, that is the universe, but the universe at large, that includes us and our brains, we discovered about 100 years ago that this reality is not there forever. It's in evolution. It has a history. And we are now lucky enough that during this past century, we've been able to reconstruct this history. And it's quite clear that the reality, that is the universe, went through very different phases in its history, which we followed for about 13.8 billion of years. And the result of this long history is that suddenly, in one place at least, in the universe, we were able to look back and understand this history. And we now know that we are part of this history. So I can try to give you some emotion about this with words. And I can say, in this moment, all of you have the blood flowing in your vein. And one element in your blood is the hemoglobin, which is fundamental because it's carrying oxygen in all the tissues. And one chemical element in hemoglobin, which is vital to that, is iron. Now, all the atoms of iron that are flowing in your blood at this moment, in our blood in this moment, all of them, none excluded, was formed at the interior of a star, which cooked all these elements in the interior and then exploded and spread all these elements around, and then they are coming back to you. So we are part of this universe. And I can try to give you emotion by saying this in words. But the fact is that if you live in a place where there is dark and there is no artificial light, like as I had the fortune to see that from the Atacama Desert in the Chile Andes, where there was absolutely no light for about 300, 400 kilometers around. And then you see the universe, the star and the universe as it is, and as it was visible by our ancestors for millennia. Then the same emotion comes directly to you without words. And then you can put together your knowledge, your rational knowledge about the universe, with the vision that you have of it, and you feel really part of it. Now, a great part of the people now has been taken out of this. They have no possibility of seeing that. So, if you are conscious of this, then you should look back in the way you are illuminating the inhabited zone. And of course, I'm not saying that we should not illuminate that. But we should act in a way that at least we limit this light pollution. For the first thing that you want to do is not to illuminate up in the sky. Not to illuminate that with LED with a lot of high content of blue light, because that is particularly diffusing in the sky and making the sky bright, and so you cannot see the stars. Then you can use other tricks like illuminating only when it's needed, and now there is the possibility of regulate timing the lighting. And you can use all this in a way that you create a conscience to this society that is important to use light consciously. And we have learned a lot of using the light very intelligently to recreate and to be friendly to human. But being friendly to human means also not to exceeding lighting and allow people to live also for part of the time in darkness. Because then you can reconnect to the sky in the same way as the population for millennia. Our ancestors had this possibility, and we lost that now. So let's be conscious and look at ways of using new technology like LED, but not only that, all the intelligent possibility of eliminating lighting when it's not needed. Why do you want all this commercial light up during the entire night when after midnight maybe there is only few population looking at that? So let's switch it off. Why should we continue to use that? So all this should become part of the conscience of the society, so that we push for the people who are building and making the illumination conscious also of this moment.
Roger, are you conscious about that, night skies, and when you have a new project?
First of all, I'm completely impressed by the view, right? The vision that we are part of the stars. It's of course very true, but I didn't really realize it in such a way, relating it to the iron in our blood and everything like that. It's really amazing, and thank you for that. It's like one of my main takeaways of Euroluce this year. Secondly, the stars are some kind of information, and I think we all have the right to gather information. So we're taking away not only a connection of the people, but also a right by illuminating the sky. I also wanted to say that it sounds like a paradox what you are explaining, because an LED is so small that within an optical system it can be very accurate. There doesn't have to be any stray light or spill light or anything like that compared to those big bulbs that we had before. The fact that it is so small should make a much more precise lighting instrument if we only want to make the effort. It's only about that. And the last thing I want to say, and then I'm done. It's a real-life example again. My lighting master scheme for the city of Barcelona, which I did in collaboration with Vicente Gallard, at that time the chief architect of the city, it contains a very important paragraph to your point, which is that illuminated advertising is forbidden all over the city. And it got approved.
Yeah, Barcelona is quite good in that regard, though, in terms of regulating night lighting. We're probably going to talk about it more tomorrow as well when we talk about light for spaces. But I know, and I don't know who wants to answer this, but it's just sort of, I'm just playing devil's advocate in a way. Because obviously it's very important to regulate our night lighting, but also cities like New York would not be New York if they didn't have their bright lit up skyline. So I'm not saying I 100% agree with it, but it is a counter argument in a way. I'm not saying all cities should be like that, but in a way New York is defined by that night skyscraper vista.
I'm just going to put in a bit of, for this system, it's a measuring system. So if you think about going into, it's a context-driven system. So if you think about, we all think the light in here is fine now because we've got used to it. If you were to go outside, it would suddenly feel very dim in here. So if you were to dim the lights in a city by 10% everywhere, then the balance would remain the same, but the light pollution would drop. So what I'm saying is that when we look at skylines and working with Spiers Major in London, what we're looking at is how we can simply dial down the lights everywhere, and everybody gets a shout, but the shout isn't so loud. So I think that there's a way of thinking together about the way that the system balances light, balances our perception of light. It's not about kind of living on dry bread and not enjoying the joy of a kind of a city lights, but it's about enjoying the joy of city lights in perspective or in moderation.
So yeah, I mean that would I guess involve all stakeholders, but you're saying you could just collectively turn the dial down a bit, and you might not even perceive so much the difference, because everything is still in the same
It's same balance. So in interior lighting, there's obviously emotion, but the science suggests that you can dim the lights by about 20% without people actually noticing, if it happens gradually. So those are ways that you can zone spaces or zone cities to create a balance or a variation and an interest in the space, without it being and reducing energy and reducing some of that those light pollution effects. So, that's my answer.
Nicholas, how do you approach these issues?
Yeah, I mean it's a really complex one because whilst we love dark skies, I love astronomy. I've done astronomical courses and things, and I love to look at the night sky. And it is, as Piero says, it is something that connects us to our ancestors. If you go out into a desert and look at the stars and actually see the Milky Way and the night sky properly, not just the odd dot here and there as we often see if we're looking at that, it does connect you to your ancestors. You do feel something, a part of the universe, and something very different, a very deep emotional experience. So we are really keen to, avoid overlighting buildings, using too many uplights, etc. So, and there's lots of dark sky regulations, and lots of people asking us to comply with dark sky regulations on projects now. So it is something that's improving, and I think we are in a good technological place that we are getting Dali dimming on facades and landscapes now sometimes, certainly on facades. Landscapes, it's coming in a little bit, we're getting a few projects like that, whereas before, in the old days, it was metal halide, it's 100%, and you got what you were given, and that was it. So technologically, we can do it, and as Roger says, LEDs are precise optical instruments. We should be able to aim them so they only point to where we want to go, and there's no spill into the sky. We should be able to put louvers and adapt them and snoots and things to make sure the light goes where it should go and not be spilling into the sky, because as Piero says, anything goes in the sky is a waste of energy, a waste of everybody's time. So it is something we are working to. The one area we find really, really hard is our addiction to uplighting trees. Everyone loves an uplit tree. Yeah, and a lot of, there's other ways you can light trees, but and we've put them forward, like wrapping them with fairy lights and various different things, but when you're on some sort of serious architectural projects, they don't look kindly on festoon lighting around trees, because it feels very sort of Cancun, Mexico, beach life. It doesn't feel like a serious urban setting. So that is one area that we really struggle. Low-level foliage, we can do lighting that's like a little mushroom, so it's just pushing light down, so it's completely cut off at the horizontal, so there's no uplight spill. So we can do things like that, and we are getting there. And as I say, people are pushing us more to do that and make sure that dark skies are complied, regulations are complied with. But so I'm hopeful. But the issue being the proliferation of LEDs is crazy. They're so cheap. And so you can put so much more onto a facade and run so much more lights and get so much more, lighting energy out of that system. So people have just done it because they can. If you can, let's do it. So we do need to back off from that. And I think that one of the key and really major important things is control, as it is with all lighting. And as Piero says, after midnight, or after maybe in a city like London where it's still kicking off at 3 o'clock in the morning, after that time, why not just turn everything off? Who needs lights on at 3 a.m., 4 a.m.? There's not many people around, so it's a bit of a waste of time. And obviously the discussion we've had about the backlit signs, the dark skies regulations talk about bug rating, so backlight, uplight, glare. So one of the major things is backlit signs. They are crazily bright because basically they set them to be visible at the brightest point of the day at 12 o'clock, midday. You have the brightest, clearest sky. Those signs need to be able to be legible and be read. And they stay at that all night. So you've probably all been near Piccadilly Circus in London. You can be 2-3 streets away, and you're getting this visible sense of what's going on. There's something changing here, and the brightness of those lights from those panels spreads as I say, 2 or 3 streets away. And so, you know, it's those things that we also need to control. We've talked on projects to people about this, and they can dim them. It is possible. It's very complex, but it's possible. So again, it's one of those things that we're hopeful. We're hopeful that technology will improve and it'll become much more easy to do that, and so that we can still have those signs, but they're, you know, on a nighttime setting, so they're, you know, nice and gentle and don't, you know, spill into the night sky. So yeah, I am hopeful, but it's not to say that we're not going to go through a sort of a curve where we're going to reach a peak where most cities are crazily lit, you know, and obviously in the Middle East and other places, it, you know, makes New York look like a little backwater. You know, there's places that are just pumping light in all directions. It's not just, you know, so we are. I think it's one of those situations where we're gonna rise up, and then we hopefully get it under control and get back down to a reasonable location. But the other thing Pierre mentioned was that lack of blue light, and one thing we are trying to do more is, again, get warmer light onto facades, you know, particularly historic facades. They look beautiful in 2.7, you know, whereas before we'd tend to be 3,000 minimum, but now we're getting 2.7 or even 2.4, and some of those, you know, facades look stunning, you know, with stones and brickwork, and look absolutely beautiful in those lower, so there's a little bit less blue light there, but, you know, again, it's a work in progress.
Okay, I hope everyone can still hear with this very long announcement that's going on. They can't hear. Well, if we shout, we'll turn the mics up for a bit while they're still talking. But Pure, I want to bring you in. It's like being in an airport. I want to bring you in. Do you feel positive about the future, that, you know, this technology that we've talked about, this fact that things are more adjustable, could lead to some changes after that impassioned sort of plea to be able to see our night skies?
Yeah, I am optimistic because I see that, first of all, it is possible to control light in such a way that you get back the possibility of seeing the star. I mean, take the example of the island of La Palma, the Canary Islands, which is a place of several astronomical telescopes. Even the National Telescope of Italy is in La Palma, together with the other UK telescopes. And the regional government put a regulation that was sufficiently good to control the lighting, such that if you are there, you can still see the sky as it is. And let's wait until...
We'll wait for 2 seconds in the hope that it stops. Yeah. A small interlude. Not that small. I think they're reading the whole list, so we might be here for a while.
Well, what I wanted to say is that La Palma is a touristic island, so there is a lot of tourism there. Nonetheless, they were able to keep the lighting such a way that it was still visible. And in fact, that is paid back, because then people go there also, not only to enjoy the beautiful island, but also the possibility of seeing the sky. And this is becoming now widespread in many countries, where you create oases which are light protected. And then you can have tourism related to the possibility of seeing the sky. So you get a revenue in terms of tourism if you are controlling the lighting in an intelligent way.
Okay, I heard about half of that, but...
So I am optimistic on one side. I'm becoming more pessimistic from something different, which is not related to artificial light at night. It is related to the very large constellation of satellites that are emerging, and they are becoming so numerous that are polluting in light from sky, from the space, and there is no control that you can make that other than shooting the satellite, which is not something that you want to do. And so we astronomers are becoming more and more worried about the impact of these mega constellations. There is not only Starlink from Elon Musk, but I mean the Chinese are now launching another huge, actually two huge constellations. And we foresee that by the 2030 there might be 100,000 satellites in low Earth orbit, which will become an additional pollution in a very different way. And it will change the appearance of the sky, because many of these satellites will be visible by the naked eye, and all of them will be visible with the telescopes. So on one side, I'm optimistic on what we can do from the ground. I'm less optimistic from what we can do with people like Elon Musk.
Roger, we started our conversation talking about natural light at the beginning of this round table, and I kind of want to go back to that for a bit now. A question really of how you get the balance. We talked about the benefits of natural light, how you can sort of replicate that to a certain extent with artificial light. But then I'm interested in how you get the balance between natural and artificial, or natural and electrified. Because you said that's a big part of your work as well, trying to sort of optimize in a way natural light in your buildings.
Well, every time it is super difficult, I think. I'm always just so much challenged by each project. And I already said, I ask a lot of questions to understand it, and I think we give too many answers too quickly to really make progress in all of this. So I think asking questions, which is also very much intrinsic to science, I think it's a very good attitude to solve the challenges of having natural light in the building. Not only to balance it with the electric lighting. By the way, I never say artificial lighting, I say electric lighting, because I just learned something today, right? The lamps are also propagating waves perpendicular to their direction, right? Yeah. So it's just as real as natural light. This is made in a different way. To find that balance is very challenging. I experiment a lot. I build a big model and try to understand it. I have a lot of material samples. I go to the glass factory and ask them to make a 2 by 3 meter sample of what we developed together with the architect. And we see and we measure and we discuss and we question. And I think these are very good ways to come to very solid designs. But it takes time and effort, and you also have to be willing as a client, I think, to allow all of that and to agree that that is a good way to develop a good design. There is another challenge, which is that the natural light also brings a lot of heat into the building, right? So to get the climate in the building right, if you look at that quite bluntly, it means that you just throw in air conditioning, and that brings up the energy balance to a very bad level, and you're far from getting your, LEED gold plaquette next to the entrance or whatever it is these days. So I think here we are entering a very interesting domain, which is the total integration of light and shading devices and climate, and therefore architecture. And in my work with Lorenzo Piano, we did a lot of natural ventilation, which directly relates to the ability of the building to accept all this natural light also, and have it cooled in a very natural way again. So I think to do that properly, it requires not only the integration in the result, like it's nicely designed, but also an integration of the process. It's very holistic, and it requires a lot of expertise from different professionals to come to a good result, because it's all intertwined.
It's super interesting what you say, because we all talk about sustainability a lot, and it's such a complex topic, because if you're talking about the need to use natural light, that's one thing. But then, of course, if you're having to spend all this energy to counter all the benefits of natural light, then it's not a good thing. Shelley, maybe I can bring you in because you consult about lighting, and you talked about natural lighting earlier being this gold standard, but how do you find that mix when you're consulting with people between these two worlds? I don't want to use the word artificial again because I get told
No, I
off
think
by
that was a
Roger.
really great point. Actually, it's electric versus sunlight, I guess, would be the difference. Yeah.
Skylight.
Skylighting. I think it really depends on someone's appetite. I mean, how early on you are in the process. If you have the luxury of designing a building from scratch, you can go back to some of the traditional things that the great city planners, the great ancient architects used in terms of where buildings were situated and how they related to the landscape and other buildings. So, and how air and water moved through that part of the land. But if you're looking at a retrofit, we can start to look at technologies like electrothermic glass. We can look at lots of other forms of shading, even just manual shading, because we see buildings with these giant glass facades, which look great from the outside, but they aren't often cleaned, and people don't know what to do when it gets too bright in there. So I think it's to do with, as you were suggesting, a systemic approach, and engaging the users in the kinds of activities, the kinds of behaviors that are going to allow them to keep the building comfortable and beautiful and uplifting. So does that answer your question?
I think it does, Shelley. I mean, we've got about 10 minutes left, and then we're gonna throw hopefully to some great questions from the crowd. But do we think that there needs to be more education, really? And I don't know who wants to jump in and answer this, but there needs to be more education about lighting. One thing that was said to me before was perhaps the industry needs to be sharing more information about what lights do. Just like, on food, you might have, in the UK, you have lettering from A to, I don't know what it is, E, depending on how good it is, or good or bad for you. Should we have something similar on lighting? I'm not saying an A to E scale, but at least something that explains this light is going to make you feel like this, it's going to make you more alert. I don't know. Should we be moving in a direction of there being more information about light?
I guess there are two bits of that. I mean, one of them is just like an apple isn't a healthy diet. You couldn't say this apple, if you deep fry it and serve it with jam, it's not going to be healthy. So I think light is the same. It's a context. It's a story. So that's the first thing. I think it's hard to say this light is going to be good for you, and that's why human-centric products really bug me, because it's an approach, it's a way of thinking about the space. But I think I was sitting on the train from the airport yesterday, and I said, I'm a lighting person, and they went, so what about LEDs? What about, and people's level of understanding, my nieces keep on pinging me saying, well, are all LEDs bad for you in the bed, at night in the bedroom? It's like, well, probably the lights in your room are LEDs, so that's not the point. So people's general level of understanding about the light bulbs, and most of them will own about 70, just in a normal home. People's general understanding of the technology is so rudimentary that I think that would be a great place to start. And then you move up into the professional people. But sorry, what are you going to say?
I'm not so sure about that. I mean, I also don't know how my microwave works. I don't know how a hairdryer works. I don't know how my telly works. I don't really want to know at home how my lights work. I mean,
your microwaves, well, some people may say it is, but isn't that, might not be bad for you? If we're talking about lighting, we're talking about something that could potentially be good or bad, or something that could enhance your quality of life. Yes, a microwave may enhance your quality of life because you can heat something up quickly, but it's a different relationship. I'm not saying you necessarily need to know how the light per se works, but perhaps you may need to know more about the type of light that's in it, how it could be beneficial to you, because we're talking about light for life. We're talking about how light can improve your life, and perhaps having a modicum of more of information could help you, not exactly how it works.
Well, that's a good point. And but I also think it has a lot to do with whether it feels good, right? The lighting at home. So you may make a mistake and buy a lamp that is not right for your home or your feelings, and you get another one, right? I mean, it's so personal and so individual. I don't know. I mean, you mentioned education. I think what is ultimately gives more positive impact is to educate architects, for example. I mean, they are in charge of a lot of buildings, not all of them, of course, but they could really benefit, I think, from understanding light better. It's really surprising that, I don't know if there are many, who is an architect in this audience?
Raise your hands.
Not too many.
Well, a few.
No, well, a few over there.
Some here, some over here.
I dare to say that there was hardly any lighting education in your curriculum. Hardly any, not too much, right? So I decided to organize a masterclass. I teach 10 days in July in Naples, here in Italy, and I target specifically architects who are in the beginning of their career and who want to grow into, I mean, they stay an architect, but within the office, within the practice, they become a bit of a lighting expert, right? And I think that's very good. I think it's interesting, it's fascinating, and it also helps to make buildings a little bit better.
I guess I'm a trained electrician, and I know that most electricians have no idea either. They just buy. So if you're having your kitchen redone, they'll say, oh, you want 10 downlights there. We've got some in the van. There you go, love. That's it. And those downlights will sit in your kitchen until you sell them forever, or in landfill. But so I mean, I think there are touch points like the architects that could be really useful as ways into that. You're right.
But I think that education from the very basic level, I think it will be certainly very important, because I mean, what I see is that technological advancement is so fast that cannot keep track with the usual education. For example, I mean, realizing that the sensitivity of the eye is matching very beautifully the light coming from the sun, filtered by the atmosphere, which means that the evolution of man developed the sensitivity in such a way to use in the best way what was available. Now we are changing game because we know how to produce light in a different way, and telling people the difference, and making clear that LED has a totally different way of creating. It's not a continuum light. It's just a light coming only in different wavelength combined, makes you conscious of what is happening. And so, for example, I didn't know about the impact of the blue light on melatonin cycle. And once I understood that, then I said, then I can sleep better if I control the light. If I wake up at night to go to the toilet, I now know that I should not switch on the light, because then I will get my sleep disturbed. All little things make living better. So education is fundamental, but it has to be matched with the knowledge about the technological advancement. Otherwise you say, I have this LED light, I switch it on, very good, I see very well, but I don't know what is the effect on my body. So I think that there is a lot to do with the education at large.
Okay, well, we're going to throw to questions in a couple of minutes. This is I started going around you all with a little introduction. I'm going to finish with going around you all. One habit that people here could change in regard to light or lighting for their benefit. Quick fire round. Each of you has to respond to that. Put you on the spot. One thing that someone could change, like you said, don't put the light on when you go to the bathroom at night. That's something you could change to improve your relationship with light or lighting. So, any thoughts, Shelley?
Well, yeah, not turning on the light at night, but also if you can get outside first thing, even if it's drinking your cup of tea or checking your messages. You don't have to be doing anything particular outside, but get close to a window or go outside for at least half an hour if you can, all through the year. It's actually protective against seasonal affective disorder, a whole bunch of other stuff. So if there's one thing you can do is to set your alarm to get some time outside.
Okay. The designers over here.
For me, it would be buy a dimmer, use it at night, and get warm light.
I would say more or less the same. I mean, in winter, after 10 p.m., only candles at home.
Okay, full on Scandi warmth there. What about you, Piero?
Well, for all of you, go back home, look around your lighting in your house, and if there is any light which is putting light up, change it.
That's his single mission for dark skies. Well, listen, amazing. Thank you. We're gonna throw to the crowd now. Throw to the audience. There's one over here, down on the bottom right. Actually, I need to take a microphone because I was told we didn't have enough mics. So then, can someone grab this and here you go. Thank you. Oh, you do have a mic. Shall I take it back then? No? I was told there weren't enough mics to go around, but it seems like there are. Oh, there's someone. This gentleman doesn't have.
So there is a small initiative that we have taken in our country in where we have created a small experience center and we try to educate people.
Can you turn the mic up a bit? Sorry, we can't hear.
So am I audible now? So we have taken this small initiative about telling these architects and interiors about how the placement of lights is all about. So how it is affecting our lens and what light pollution is about. So, and second, so I have two questions. So once you are discussing about light pollution, first of all, so what I think is that public highways is one thing and facades and skyscrapers lighting. So these are like the major factors in which we see that the light is spreading in the whole area. It is not falling downwards, it is just spreading out in the whole area. So what are the initiatives that we can take other than dimming the lights?
Is that a question for the whole group or? Yeah. Who wants to jump in?
First of all, what's your name and what is the country that you are from?
So I'm from India and my name is Manu and I'm third generation into this business now, so I'm very much fascinated about lights.
Manu, welcome to the show. All right, so instead of only dimming, you should look at to what extent the lamps that you use, the fittings, are shielding the light. So you need good optics. And you need transparent covers instead of milky. You need light that is directional. And then you can aim it downwards and you don't have the pollution to the sky.
Yes, I fully agree. I mean, the point is to direct the light as low as possible in the place where you need it and to avoid any spillover that goes up to the sky. Of course, there is light reflected by surfaces, vertical. That is more difficult. That you have to have surfaces that are not so reflecting, but that might be more difficult. Certainly, all the advertisement and commercial which are vertical, they are really killing because they are diffusing the light up, and so that should be avoided if possible at all. But that, again, is against commercial interest, and so it's more difficult to achieve.
Because we do lighting for heritage properties in India, the outdoor facade lights. Usually, we are placing lights downwards, just so that whenever you are walking by, it doesn't come to your eyes directly. Instead, we are placing it from the top. So is there any better solution for that?
Just one other thing. I've been talking a lot to people at Bureau Happold, for example, about smart infrastructure and how we can now use the way that sensors can tell whether a car is coming, it can tell whether a train is coming, it can tell whether there's a pedestrian, and it can start to change how much light is there. Because we need light to feel secure and to move around, but we don't need it on when we're not there. So maybe thinking about smart infrastructure could be another way of approaching this problem.
Anyone else want to chip in, or we'll go to another question? Who's got a question for us?
Thanks for your question.
Over there.
Thank you. There's a lady over there.
Thank you. So my name is Elena Scaroni, and I'm the Secretary General of Lighting Europe, which is the European association representing the lighting manufacturing industry. And it was amazing to listen to this panel, honestly, and our members would actually fully agree with what you said. Actually, I heard a lot of things we also say in panel like this one, and it's amazing. We believe that we should definitely minimize the impact of lighting on the environment. It's a very strong position we are taking in Lighting Europe. And we believe that one of the solutions could be harmonization of regulations. around lighting. So we should harmonize how we regulate light pollution around Europe and hopefully around the world. So my question for you would be, would you agree that that could be part of the solution, harmonization of rules, and what needs to be done to get there? Because it seems really, really difficult to get there. Thank you. It's a question for any who wants to take it.
I think that would be really helpful. Obviously, one thing we find is that you jump from one project to another and you get a different regulation, and they're all slightly different. So it does make life a little bit more complicated for us, and I guess also complicated to enforce those regulations, because obviously they're different in different places. So I suspect getting the whole world together would be fantastically difficult, but certainly a European-wide regulation would be great. It simplifies it, and we are starting to see there's certain countries like Saudi Arabia where we do some projects, and at the moment it's split into regions, and they're trying to join together and get a global regulation. So I think anything that simplifies it means that it's probably more likely to happen and more likely to be followed. So yeah, would totally agree with that.
First of all, I think the adopting regulation that are followed is always very difficult. However, by trying to create regulations and making them known internationally has also an effect. Now, the International Astronomical Union, which I represent, is discussing with the CIE, with the Commission Internationale de l'Éclairage, to have an agreement so that we can promote good practices and regulation. And I think that the more you're able to make them known globally and justify them, then you can achieve something more than just trying to impose regulation, because that is more difficult. And in fact, if you try to do that, you may get the opposite effect. So convincing people is the key.
Roger?
Well, thank you for that question, because it applies to all of us. And I think the main thing that we can do, well, first of all, these different regulations are pretty similar. There's not a lot of difference between, they sometimes describe it in different ways, but they're all about saving energy, avoiding skylight, compulsory switching scenarios. I mean, they all describe all of that. So there's not a hell of a lot of a difference there. I think these regulations are far too complicated to be understood and applied by normal people. I mean, you really have to make a whole study to understand it, and you become a lead certified consultant or something, and otherwise you're just puzzled by the complexity of it. So I think as an industry, you can also help to make this kind of information much more accessible and simple and easier to apply for the rest of us. And I also think that the manufacturers themselves, with their technical documentation, can make it a lot more accessible. It's just really complex. There are way too many luminaires. There are way too many numbers in these catalogs. It's just complicated. I mean, we understand it, but for a lot of people, it's just too much. So all lighting will get a lot better when, first of all, this kind of information that you need to do it right is simple and accessible.
And I think, just to add to that, is there need to be some baselines and then some spaces for interpretation. Because when we have connected load, for example, or lumens per watt, you end up with some unintended consequences, which mean that the quality of light is not integrated. So finding ways of creating the baseline and zones for interpretation makes a big difference too. Or means that we don't end up with unintended consequences of a number. But I'm with you. I think having something that's harmonized will actually allow us all to have a common language and move the buildings that we live in, move them forward into a place where they're worth living in.
Okay, any more questions? Anyone else want to ask a question? Got time for a couple more.
So, hello. So first of all, I am very thankful for this talk. It was highly educational, and I've learned a lot of things through it. And I'm also very honored to ask a question to a very experienced cast. So, speaking of experience, do you, in each of your illustrious careers, do you have a special piece of work, something that inspires you? It could be a milestone, or a certain usage. I know Professor Piero Benvenuti talked about La Parma. So what is your La Parma?
The question is whether each of the panel have something that inspires them.
Yes,
Yeah, okay.
an important piece.
Something important to them. But it can be something. It can be anything. It can be music or anything that they draw inspiration from.
Yes.
If you have something that you draw particular inspiration from, like a piece or some music or...
Well, my inspiration from the beginning was really looking at the stars. And I was a kid. I was, an uncle gave me a very small telescope with the dimension of the Galileo telescope. So 4 centimeter was the objective. And I was able to see the satellite of Jupiter with that and following night by night their movement. That was very exciting, and I still remember those moments. And so that was the thing that inspired me. And then when I saw the sky from the Atacama Desert was another emotion that I cannot forget. And so those are the things that emotion me. And I linked that, however, to music, because I feel that looking at the sky is very similar like listening to a Bach piece of music. So I find, for some strange reason, that the two things are very well connected.
I think I'm lucky enough to have lots of young people around me, and they inspire me because I think, what can I do to make the world a better place for them? I see them go to school. My goddaughter struggles with learning, and she's in a space which is really not it's like a hospital waiting room. It's really not comfortable. And I have some friends who are in residential healthcare, and they inspire me every day. I think, how can we create spaces that are fit to live in? And so that's my inspiration, is to make places where people that we're proud to leave behind. So that's my inspiration.
I think obviously the stars are a great inspiration to everyone, but for me, for one of the projects or designers or artists who really inspires me is James Turrell. We talk about proliferation of LEDs, and one of the things that happened with LED is color light became very cheap very quickly. So we got a lot of very, very bad colored schemes just happening all over. And I like to remind people that James Turrell is basically RGBW or RGB lighting just done very, very, very well. And and again, going back to what we always say, it's about control. Some of those James Turrell pieces that change over hours and stuff, it's absolutely stunning. And that's all about control, which is what we always bang on about lighting as one of the most important things. So yeah, that was for me.
What is your name and where are you from?
My name is Julien. I'm a second-year student of engineering in France.
Thank you.
Enchanté.
Thank you. Enchanté. Look, when you make a design, there is a stage that you brainstorm, and it's about concepts. And a lot of us think that that is a very important stage in the design. And then there is in the middle something where you get approvals and you decide how to proceed. And then there is, in the end, the detailing and the nitty-gritty and all of that stuff. Actually, the RIBA considers 7 stages, but it's often a lot easier, right? So for me, the inspiration is in that final stage. I think you get all of your ideas for the next project by detailing. So since you are a student, I want to say that the ability to detail your ideas and to make them real, what I said in the beginning, to turn an idea into an experience, that is the most important thing to do.
Thank you very much.
We're gonna have to wrap it up, sadly. We're out of time. We had an amazing conversation. I just want to thank this incredible panel for their... Give them a round of applause, everyone. Thank you. It's been an absolute pleasure. Thank you very much.